Good morning. Today I'm going to go over the two type 7 problems I assigned you for homework. The first question was question 3 from 2007. This problem was, I know it says calculator active, but it is not calculator active. So let's get into it. It says the function f and g are differentiable for all real numbers. This means that right there, if we are differentiable, we are continuous. I'll write that down. And g is strictly increasing. The table above gives the values of the function and their first derivative. At select values of x, the function h is given by h of x equals f of g of x minus 6. So I pointed this out in the other video, but this should immediately make you think chain rule. Derivative, right? Might not need it, but at least you can recognize it when you look at it. Okay, so part A says, explain why there must be a value r for 1 to 3 such that h of r equals -5. So part A is a classic IVD problem. So the first thing we need to figure out is who h of 1 is and h of 3. So h of 1 is going to be equal to f of g of 1 minus 6. H of 3 is going to be f of g of 3 minus 6. G of 1 is 2. So we've got f of 2 minus 6. G of 3 is 4. So then we have f of 4 minus 6. Let's do these together. F of 2 is 9 from the chart above, so 9 minus 6 equals 3. H of 1 equals 3. F of 4 from above is -1, so -1 minus 6 equals -7. Okay, so the first part is making sure that we can figure out h of 1 and h of 3, which is simple substitution. And then we're going to write since h of 3 is less than -5, and which is less than h of 1, and h is continuous, by IVT some value of x equals r exists. And there's a couple ways to say it. You just want to make sure point-wise that you have found h of 1 and h of 3, and that you use the conclusion with IVT, right? So we have to state that it's continuous. This would have been worth 2 points. You get one point for getting h of 1 and h of 3, and then your conclusion. Okay, part B. Explain why there must be a value c for 1 to 3 such that h prime of 3 equals -5. So the work here is we need h of 3 minus h of 1 over 3 minus 1, or a rock. We need to figure out what that is. The good news is we already did h of 3 and h of 1 in the last part of the problem, so we can just kind of borrow that. I believe we get -5. And so because we get -5, and that's what we're looking for, we need to state that h is continuous and differentiable. Therefore, by MVT, there exists some value c such that h prime of c equals -5. Okay, this one was also worth 2 points. We got a point for AROC, and we got a point for our conclusion with MBT. So again, make sure we show that AROC and MBT. The conclusion would have to say this continuous and differentiable because those are their half-twos. All right, next part, part C, says let W be the function by W of x equals the integral from 1 to g of x of f of t dt. Find the value of W prime of 3. Okay, so part C, we have this integral expression. Is that an x up there? That 1 to g of x, this upper bound function of f of t dt. And what we really need to figure out is we want W prime. And so in finding that, we have to take the derivative with respect to x of this function on the right. Now, when you take this derivative, you have to really understand, and I think this is something we might see this year, that the derivative and the integral are opposites of each other, or I should say opposite operations of each other. And so this is the fundamental theorem of calculus 2, I believe, that we go back to the idea that this is a difference quotient, right? And so the derivative of whatever this function is at 1 is a constant and therefore is 0. So you take, what you're in essence going to do is you're going to take the function, plug in the upper bound function, but then multiply it by the derivative of that upper bound function. So in order to get W prime of x, that's all you need to do here. You don't worry about the constant because again, the derivative of the constant is 0. Now we're going to plug in g of 3 times g prime of 3. That's a W prime of 3. Make sure that you always acknowledge what you're talking about. Don't put W of x there. G of 3 is 4. So we have f of 4 times g prime of 3. If I go back and look at the chart, f of 4 is -1 times g prime of 3. Where's g prime of 3? Which is 2. And so I believe this is -2. Final answer. Okay, and then the last part is that inverse relationship idea. The question says if g inverse, g to the -1 is the inverse of the function g, write an equation for the tangent line of the graph of y equals g inverse of x at x equals 2. So the first thing you want to do is you want to go figure out where it is true that g equals 2. You go to g, this column, it's right here, and that is at x equals 1. So we're going to put g prime of 1. This will mean that g inverse of 2 equals 1. And by the definition of an inverse derivative, we are looking for 1 over g prime of 1. So you take the point and you're looking at that x value, what it is. And so our g inverse of 2 is equal to 1 over 5. 1/5. And now we're going to write our tangent line. And so our tangent line, remember our x value is now 2. It states it in the directions. We've got y equals 1/5, our slope, x minus 2 plus 1. And so you get a point for the tangent line. You get a point for finding the derivative and a point for identifying that we're dealing with the number 1. In part C, you get 1 point for applying the chain rule and 1 point for the answer. Okay, so as you grade that one, please make sure you just go back and double check your points and put that into the Google form. Okay, the second problem I assigned was number 6 in 2003. What we see here is we see a piecewise function. Is f continuous at x equals 3? Explain why or why not. So continuity exists if the limit as x approaches, in this case, 3 from the left and the right. I'll write proper notation, I apologize. As x approaches 3 from the left and the right of f of x equals f of 3. Okay, so part A. I want to look at the limit as x approaches 3 from the left of f of x. And so that's the top function. So we're going to plug in 3, and I believe we get 2. And the limit as x approaches 3 from the right of f of x, we're going to do 5 minus 3. And so I believe we also get 2. The point for this function comes from this side, which we know to be 2. So we would write f of 3 equals 2. Therefore, f of x is continuous at x equals 3. And that is because the limit as x approaches 3 of f of x equals f of 3. So this problem, there were 2 points. You got a point for answering yes, right? Yes, it is continuous. And then your explanation involved the limits. Part B says to find the average value of f of x on the closed interval from 0 to 5. While this problem is not something we're going to see average value, you might have to take the integral of a piecewise function. So we're just going to go through it. Average value just adds a fifth in this case out to the beginning. So we know that average value is going to equal 1/5 of 0 to 5 of f of x dx. Our 1/5 is going to stay outside. We're going to have to break up our bounds, right? So we've got a 1/5 times 0 to 3 of f of x dx plus 3 to 5 of f of x dx. Integrating those functions within pieces, we have the square root of x plus 1, which is really x plus 1 to the 1/2. So to integrate that, we're going to add 1 and divide by 3/2. So this first piece is going to be 2/3 of x plus 1 to the 3/2 plus our other function was 5 minus x. So that's going to become 5x minus 1/2 x squared. So we have 5x minus 1/2 x squared, and we have to evaluate that from 5 to 3. We have to evaluate this from 3 to 0. So our answer is going to be 1/5 times 2/3 x, 3 plus 1 to the 3/2 minus 2/3 of 0 plus 1 to the 3/2, right? Plus 5 times 5 minus 1/2, 5 squared minus run out of room. 5 times 3 minus 1/2 3 squared. Room and battery. Okay, and so then I would leave it like this. This is your final answer. You are not to probably figure out what that number is. Interestingly enough, it turns out to be 4/3. You'll have a calculator on the exam, so these will be easier for you to do because you could certainly put this function into and get the integral and add it to this function and then divide it by 5 should you be given this question. So what you had to do was identify that you had to break up the bounds. That was one point. You had to have the antiderivative of this correct and the antiderivative of this correct, and then your evaluation with your answer. So it's a 4-point question. Part C, I went over a little bit in our morning session. Suppose that the functions are defined by g of x equals k root x plus 1 and mx plus 2 for the other half. I'm not going to write it all down. You can look it up at the top. So it wants to know if g is differentiable at x equals 3, what are the values of k and m? So once we hear that it's differentiable, that indicates we're going to have to take the derivative. So if we are looking for this to be differentiable, it means it had to have been continuous. If it's continuous, then the left side has to equal the right side. Okay, and then you're going to plug in the value they give you, which is 3. This is all at x equals 3. So k of 2, or as CJ likes to say, 2k, equals 3m plus 2. That is 1 point. If you do nothing else, you can get that point. Then we're going to take the derivative. The derivative of the left should be k over 2 square root of 2x plus 1, just following that, the square root of x equals 1 over 2 root x idea. Equals the derivative of the other side, which is just m. We're going to still plug in x equals 3. And so you should get k over 2 times 2, which is 4, equals m. All right, so now what we're going to do is a little bit of systems, a little bit of algebra. And the old test was like this. They love to throw in the algebra. This was your second point, by the way. So you got 1 for setting it up as continuous and 1 for setting it up as differentiable. And now we're going to put those ideas together. So we got 2k equals 3m plus 2. And we've got k equals 4m. You can substitute in any way you like. Today I'm going to substitute this one in here. So I've got 2 times 4m equals 3m plus 2. So what do I have here? 8m equals 3m plus 2. So m is going to equal 2/5. I'm going to take that m and put it into for k. So we got k equals 4 times 2/5. And that should be enough for your answer. And so that the values of k and m, were only worth 1 point together. So you had to get them both. That is the overview of these two types of problems. Please like and comment and share your thoughts.